lecture. I did not send new presentation this lecture because this topic we need to read. My goal today is explanation of the very complicated things. This topic, hemodynamics, blood pressure control, I think Saftarin, the most complicated. It's the most complicated topic. It includes physics, laws, a lot of information, but it's an important topic for your profession also because microcirculation around teeth, masticator muscles are important for maintain health, oral cavity, masticator and function. Those are the topics important. You will have to with cardiology later, and internal diseases, microbiology. I'm going to talk today at first about hemodynamics. Hemodynamics is a science about science describing laws of blood flow within blood vessels. Hemodynamics is a science about mechanism of blood flow. How blood flows along within blood vessel. What does it mean? Second part of lecture will be about some details of blood vessel regulation. Local regulation of blood vessel tone diameter to provide microcirculation and organ perfusion. And the last part will be about blood pressure and blood pressure control. 3 parts. And first, hemodynamics. Come in. Hemodynamics. Hello, come in. At first, I remind you circulation, blood in our body, and explain levels of the blood flow in systemic circulation and pulmonary circulation. Right part, left part, right part is smaller. Aorta, then organs, simple scheme, organs, arterial part, then venous blood, capillaries, venous blood. Now this is just simple scheme to explain hemodynamics. And come back to the right atrium, vena cava or vena cava, no, inferior vena cava. Vein, but both veins are systemic circulation. And pulmonary circulation. Pulmonary circulation, venous blood, venous in accordance with composition. Right ventricle, then go to lung, pulmonary artery, here aorta, pulmonary artery, lungs, into lungs, gas exchange here, and come back to the heart, pulmonary vein. We talked that blood flow is defined at first by pressure gradient between the beginning and the end of circulation. What about blood pressure? Blood pressure is a little different during systole phase and diastole phase. During systole phase and diastole. I will show here approximate average values of systolic blood pressure, systolic blood pressure inside the ventricles, right, and diastolic. Systolic blood pressure at rest in adult person at rest in utero. 120 millimeter Hg during systole phase and about 0 during diastole phase. What about right part? Right ventricle creates makes lower blood pressure to provide lower hydrostatic pressure in pulmonary circulation to escape and prevent edema and filtration of liquid fluid in lungs. About 25 during systole phase and again about 0 during diastole phase. 25, 0. Atrium, right atrium has about, it's very average, about 3 millimeter Hg. It can change during the systole diastole phase, about 3, and left about 5. It's approximately. Cardiac output in systemic circulation and pulmonary circulation must be equal. Cardiac output is equal. Cardiac output, right, must be equal. Cardiac output left. The amount of injected blood per minute. This is pressure gradient. Usually scientists medical worker use another term describing pressure gradients. This term is called mean pressure. What does it mean, mean pressure? I will show on the special graph. This graph reflects a real record, pulse pressure in your blood vessels. You can record it, for example, with your phone, mobile phone, if you have special application. Rising phase reflects inflow blood to the vessel, this vessel during systole phase, and another part, diminishing part, reflects outflow. So we have two gradients of blood pressure, diastolic blood pressure, systolic blood pressure, diastolic and systolic blood pressure. Difference between them, mass difference, systolic minus diastolic, is called pulse pressure. Pulse pressure. For example, your systolic blood pressure 120 millimeter Hg. Diastolic blood pressure 80 millimeter Hg. What will be the pulse pressure? How many millimeter Hg?
40.
40. Blood pressure. What is a mean blood pressure? Mean blood pressure is calculated with special equation. Mean blood pressure equal diastolic blood pressure plus 1/3 pulse pressure. As pulse pressure here 40, 1/3 from this is about 33, 15. In my example, in my case, diastolic 80, so it will be about 93 millimeter Hg. Mean blood pressure is closer to diastolic blood pressure than to systolic blood pressure. Approximately here. Why? What is the duration of systole phase at rest? Systole phase, about 0.3. What is the duration of diastole phase? About 0.4. Diastole phase usually more long lasting. So it gives more value into mean blood pressure. Therefore, mean blood pressure is closer, a little bit closer to diastolic blood pressure than to systolic blood pressure. So mean blood pressure in systemic circulation, mean blood pressure, aorta, mean blood pressure in aorta about 100 millimeter Hg, and in veins it's about the same, maybe from 1 to 4. Mean blood pressure, it depends on some factors. I will explain now some factors. For example, inspiration, expiration, your breathing, nafas, breathing from tall blood vessel, and many factors about this. What is the mean blood pressure in pulmonary circulation? Mean blood pressure here about 50. Mean blood pressure about 50 millimeter Hg. Much lower compared to systemic circulation. Now, this is principal numbers, important numbers for us. Then, next, very important term. Medical worker, doctors operate with two terms describing velocity, speed of blood flow. Blood flow, Q, blood vessel, model blood vessel, blood flow marks with letter Q, blood flow Q, is the total amount, volume of blood inside blood vessel, flowing across blood vessels, one square cross section per minute. Q is volume. It means volume of blood. Volume of blood flowing across total across cross section area per minute. How many milliliters blood is flowing across cross section per minute. At rest, totally in the blood circulation, circulation system, pulmonary circulation equal in systemic circulation, blood flow for within all blood vessels, cross section of all blood vessels, all arteries or all capillaries or all veins cross section, equal cardiac output. I mean here all circulatory system, not one blood vessel, all circulatory system. So total blood flow in all blood vessels is equal cardiac output. 5 liters, about 5 liters at rest. But it's very important to understand this blood flow, 5 liters, will equal cardiac output in all blood vessel of the given type in this circulatory system, systemic circulation or pulmonary circulation. So we have series arrangement of blood vessels, different types, and in each type, across each type, 5 liters flows per minute. Now, I will clean this skin because I need more space. And I'm going to draw another skin, very important skin, key skin And I will ask you during colloquium, very important. Key is key. At first, model of different blood vessels. Did you study blood vessels in histology?
Yes.
The skin just for systemic circulation. The first, largest, biggest blood vessel, aorta. Then, what next type of blood vessels?
Veins.
Elastic aorta, no, large elastic arteries, branched aorta. Large elastic arteries. Aorta is single blood vessel in systemic circulation. Large arteries. Next type.
Mix.
Muscular.
Mix and muscular.
Medium. With medium diameter. Muscular arteries. The body has more muscular arteries, so this circle means cross section, total cross section of this type of blood vessel. One aorta, small because just one, single. More large arteries, total square more. Another type of arteries, muscular arteries. Then arterioles, bigger arterioles. Then capillaries. I don't have space. I will repeat, but I need to clean everything. Okay? Because very important. And I advise copy this picture. Again. Aorta, large arteries, aorta, large arteries, next medium arteries, then arterioles, then next blood vessel.
Next, arterial.
After smallest arteriole.
Which arteriole?
No, that's some
Capillaries.
capillaries. A lot, the biggest, square capillaries. Capillaries. Next, venous. Smallest venous. About this. A little smaller than arterioles. A little smaller. Then veins. Okay. Veins. And last.
Arterial.
No.
Last
blood vessel. Vena cava. Vena cava, one inferior or we cannot consider both. Vena cava. Vena cava, we have a superior and inferior. Inferior is the main, but superior has position also.
Always in the arterial.
Vena cava, right atrium. So these circles are cross-sectional area. Total cross-sectional area of all blood vessel, this type blood vessel. All large arteries, medium arteries, arterioles. About blood flow. What about blood flow across this cross-sectional area? Is it equal or different?
No equal.
No, it's different. Blood flows different.
No, equal. 5 liters here, 5 liters here, 5 liters here, and each cross-sectional area
In the capillary.
is equal. Q is equal.
Blood pressure, capillary.
Professor, you mean the volume?
Blood volume.
Okay. It's the same.
Blood pressure.
5 liters. No. Blood pressure.
Say blood pressure.
No. Blood volume equal. 5 liters. That's about 5 liters. It may be more, 5 liters more or less, depends on gender, size of
Continuously.
but it's average. Blood pressure is not equal, of course. I will draw blood pressure gradient, systolic blood pressure, diastolic blood pressure. They are very different in the large arteries, in aorta. So then it becomes a little more in large arteries due to some physical loss. Then again with wave blood pressure with difference between systolic and diastolic. And then less wave fluctuation. And at the beginning of arterioles, these waves becomes like one line and transfer to line without fluctuations due to absence of smooth muscle cells in capillaries. And blood pressure then falls to about 3 millimeters. And capillaries about 10 millimeters. About 10. And here we can use mean blood pressure. Mean blood pressure will be like this. Mean blood pressure. And what about another term of blood circulation? It's called blood flow velocity or simple velocity, blood velocity. What does it mean, blood velocity? Blood velocity. Again, blood vessel model. Higher blood pressure P1, lower blood pressure P2, blood pressure gradient. Blood flows from P1 point to P2 point. And blood flow velocity here is usual velocity, centimeter per second. So it's velocity of going one particle of blood along blood vessel wall, centimeter per second. What is the difference between velocity and blood flow velocity? Blood flow is equal in each square, but blood flow velocity is different. Why? Do you remember mass operation with cylinder?
Sure.
For example, big blood vessel with a big total square and smaller blood vessel with small diameter. Here the two tubes, there are two tubes with equal blood flow volume inside. Q.
But
Equal.
the pressure will be different, right? The pressure
Pressure is different
is
also.
different.
But now I'm talking about blood flow velocity.
Ah,
Q is equal because large tube and narrow tube. But lengths of this tube different. That's it. Big cup and narrow cylinder. There's a different height. Here different lengths. There's Q equal, but diameter different, so lengths must be different to maintain equal Q. Even length of this blood vessel is like blood flow velocity. Blood flow velocity is highest in smallest square. Smallest square. I mean here all systemic circulation, not one blood vessel, all systemic circulation. Smallest square, highest blood flow velocity. I mark by the blood flow velocity in aorta is highest, about 40-50 centimeter per second. With decreased total square, blood flow velocity will decrease. What type of blood vessels? Blood has smallest, lowest velocity.
Capillaries.
Capillaries, because biggest square. So it decrease to capillaries, and then
Increase.
increase again. It becomes a little more than our. This key scheme for you to study this topic and understand the difference between them. But in circulation, we have two systems, two resistance system. I will explain.
Excuse me, I don't understand about why capillary is biggest than aorta.
Because a lot of capillaries in our body. It's a total square.
The amount
all
of the
capillaries.
capillary.
Not one. It's total square. It's very important. Total square. I will explain with a simple model. We have some artery, for example, artery is divided to branch and form another branch to supply organ with oxygen. And blood then divided to two. And we have two resistance system arrangements, two arrangements. Sequence, series resistance, that's one by one, series resistance, and another type with two blood vessels, parallel resistance. Parallel.
Oh.
Recall physics, electrical chain. Did you study in school?
Yes.
Parallel resistance and series resistance. It's the same, and physics laws are used in describing hemodynamic laws. The series resistance and parallel resistance. This is system of series resistance. But inside,
It's
between
parallel.
arteries or inside capillaries, we have parallel resistance. Here, there are some laws work. For example, what happens with Q depending on series or parallel resistance? I will explain again. Microcirculation, local circulation, local blood flow. Parallel resistance. One blood vessel divided to three branches. Q incoming blood, for example, 3 liters here, 3 liters. What will be Q in each branch? Q1, Q2, Q3.
One.
It doesn't mismatch with the Q total Q. Total Q for all the square. Here is local. Local. Due to parallel resistance, 3 liter is arranged equally between 3 blood vessels. 3 liter, 1.
1 liter.
1 liter. But here case with equal diameter of all branches. If one branch is narrow, double narrow, decreases. So this branch, for example, double less. This branch will have 1/2.
Yeah, half liter.
0.5. The rest, 0.5, will be arranged between the rest. I explained it during video lecture.
Yeah, it will be like 0.5, 1.5, and
For
1.25.
example, case when one branch constricted, double two times. Constriction. So when here we have 0.5.
Okay, it will be 1.25, 1.25.
It will be more, plus 1.25, yes, plus 1.25. Because rearrangement and total sum total sum
3 liters.
summation will be again 3
3
liters.
liters.
Yes,
Here,
yeah, confused.
summation. It will be equal incoming blood flow. Very serious resistance, serious arrangement. About Q,
شو كانت الكيو؟
serious arrangement.
ما تعرف الكيو.
Local network,
Mhm.
vascular network. One blood vessel, single blood vessel, artery, constricts. Why? For example, atherosclerosis. Atherosclerosis would be this point, or some regulatory process. Constricts, it then dilates. Dilates.
أيوه.
Q here will be equal.
Same, it will be the same.
Serious resistance. Q equal. Q doesn't change. Q doesn't change.
أنا أتعلم الفيزياء.
But blood flow velocity will be changed.
Yes.
1, 2, 3. What part has the highest blood flow?
Second one.
Second. What part has the lowest?
Third one.
Three one.
Third. So it will be like this. More and
Less.
lower. There's higher blood flow velocity here. It's medium. Here.
Blood pressure in the second one
Yes.
is highest.
Yes.
Yes, blood pressure high. I will explain that about blood pressure. Next, about serious resistance in the total systemic circulation. Serious resistance. Blood pressure control includes control of resistance in systemic circulation and local circulation. Blood pressure defines, at first, what is the significance of blood pressure? And hemodynamics, main hemodynamics goal. For what hemodynamics work in maintenance of homeostasis? What is the goal of circulatory system?
Like to provide the
Function of blood circulation. What is the main function?
provide the organs with oxygen with
Supply
nutrients.
organs with oxygen and
Nutrition.
and remove waste.
Mhm.
What blood vessel is responsible to provide exchange between blood and tissues?
Capillaries.
Capillaries. So the function of total function of cardiovascular system is the maintenance of optimal blood flow and blood flow velocity in the capillaries. It must be more or less low to give time for exchange, but it depends on condition. At rest, lower, during physical exercise, higher. Why? Because in the capillaries, gas exchange, nutrient exchange happens due to gradient between blood and tissue cells. Gradient. At rest, cell don't use a lot of oxygen and glucose. So cell contain more glucose and oxygen than during physical exercise. It's enough to provide lower speed, more or less relatively lower speed, blood flow velocity to have time for exchange. During physical exercise, cell use a lot of nutrients, especially glucose, free fatty acid, and more oxygen, and there is a bigger, higher gradient between gradient for gases and nutrients. So blood is accelerated to increase delivery. So this velocity is enough to have normal exchange due to higher gradient. With gradient higher, and blood circulation must be higher also. Different condition to provide exchange. different pressure, a different gradient between tissues in the blood, and it requires different blood flow velocity. So, a key factor to supply organ is maintenance of normal Q, blood volume inside within organ. It's called perfusion. Because Q is key integral factor. Do you remember Ohm law in physics?
Yeah.
Ohm law. And hemodynamic uses the same law, but in terms of blood fluidity, flow fluidity. I have this equation. Q equal difference between blood pressure gradient at the beginning and at the end of blood vessel, single blood vessel or total circulation, pressure gradient and resistance. Pressure gradient and resistance. What does it mean? Again, model of single blood vessel model. P1, P2, it's pressure gradient, it's easy. And resistance is the resistance to pressure on the sides in blood vessels. Resistance is an opposite force opposite pressure. It's resistance. Blood vessel has length. Blood has viscosity. All factors and the blood vessel has diameter or radius. All factor influence of blood flow. Here, Ohm law or fluid.
Ohm law.
Ohm law.
Ohm law.
Yes.
Scientist.
So scientific Ohm law. Actually, Ohm law was described at first for fluids, then for electric system. At first for fluids, because electricity was discovered after. It's easy, okay. Q is key. So we have conclusion that blood flow depends so much on pressure gradient. What is the pressure gradient? It's a circulatory system, systemic circulation. Mean blood pressure, arterial pressure, mean arterial pressure, because blood pressure is here, minus blood pressure here. What is the blood pressure at the end? It has a specific term, it's called central venous pressure. Central venous pressure here, minus central venous pressure. Central venous pressure is about zero, no, 3 it's not, about 0, so we can close this and consider just mean arterial pressure. R, what is the R? R is called in medicine systemic vascular resistance. Systemic vascular resistance. Systemic vascular resistance. Systemic vascular resistance.
Depends on the atherosclerosis in the vein
Yes,
or
of course.
aneurysm.
That depends on a single atherosclerosis. Doesn't influence, but multiple atherosclerosis is influence so much on blood pressure, it provokes hypertonia. It's very important. Yes, you are right. Systemic vascular resistance includes resistance of each part. Aorta is a short blood vessel. It doesn't have some big arterioles on it. So usually equation for systemic vascular resistance in systemic circulation will be so. Systemic vascular resistance equal summation resistance large arteries plus large arteries and arteries plus resistance arterioles plus what will be next?
Venous.
Capillaries also. Why not? Capillaries. Resistance capillaries plus resistance veins. And next resistance vena cava.
Vena cava.
Vena cava, no, big
So-
veins, big veins.
Yeah.
Here are the medium veins, here are big veins. What about amount, value, numbers of each component? What will be more, what will be less? And, for example, we will consider systemic muscle resistance like 100% total. 100%. What will be a ratio between this resistance? Large arteries about 20, arterioles about 50, capillaries about 10, and veins in the vena cava are the smallest. Here are 4, and here how many? 6, no?
16?
16. Yeah, here maybe 20.
Uh, 60.
لهوي 60
Maybe
ناقص هو ده.
بتكمل 100 بتكمل 100
دول كام المية؟
50 20 70 10 80 84
كم فضل من 100؟
16
Here for 6 is 20. 20.
Uh-huh.
Again 20. Okay.
كده غلط.
So the smallest in
Why?
20 capillary.
Why 20 like arteries? Because a lot of capillaries. A lot. Total. The capillaries are arranged with parallel. Parallel circulation. But parallel resistance. But a lot of capillaries creates enough resistance. Why large arteries, medium arteries has lowest resistance compared with arterioles? Resistance is provided alone by smooth muscle. What blood vessel has more smooth muscle layer, tunica media, arteries or arterioles? Arteries. Absolute thickness is more, but arteries, blood vessels, and arterioles. Arteries has thicker.
Elastic lamina, internal elastic lamina.
Both blood vessels has three layers. Epithelium, tunica intima, tunica
Tunica
media,
media, tunica.
and tunica exterior. Exterior elastic. Adventition. But I'm talking about tunica media. Tunica media thickness in large arteries bigger than in small arterioles. Absolutely, in arterioles thinner layer, but diameter arterioles is small. So ratio between thickness and total diameter is more for arterioles. Ratio between thickness and diameter. More numbers of arterioles. So arterioles, total amount of arterioles has more vascular resistance compared with arteries. So two factors, primary factors influence on total resistance of some blood vessels. Numbers, total numbers in the body, how many are capillaries or arterioles or arteries, and thickness of smooth muscles. Capillaries doesn't have smooth muscle, but a lot of tubes. Veins are less, and veins have a little smooth muscles. It's very, very thin.
One,
Very, very thin.
one.
Very, very thin with large diameter. Large diameter. Each vein has a larger diameter due to their stretching capacity. About stretching capacity, it's called compliance. Difference between blood vessels. Compliance. What is it, compliance? Compliance. I explain about compliance. Blood vessel is tube with pressure on the lateral side from inside by blood pressure and outside, smaller outside due to interstitial fluid. It's called transmural pressure. Transmural pressure. This is difference between pressure inside and outside. Inside usually more. It's pressure inside. What happens if you increase blood pressure inside? Increase. What happens with blood pressure?
It will be dilated.
Stretch, but stretching smooth muscle increases their automaticity. They start to contract more and increase muscle tone. So stretching may provoke smooth muscle contraction and maintain diameter. And compliance means degree of volume increase, blood vessel volume increase in response to increase of blood pressure. With more blood pressure, more blood gain. Compliance,
Что значит problem?
what I explained. Compliance is ability to be stretched in response to increased blood pressure.
Zafiyet, compliance.
Compliance.
Versus zafiyet.
Zafiyat.
Sorry,
Zafiyat.
Professor, can you repeat it?
Compliance is ability to be stretched, blood vessel to be stretched in response to increased pressure inside. With increased pressure inside, the pressure extends, stretches. But blood vessel can have tone. Tone in it, this blood vessel resists to stretching force. Pressure, stretching force. Blood volume shows, vessel volume shows capacity to be stretched. What is the difference between compliance? Arteries, arterioles, and veins. Veins. What blood vessel has higher compliance? Arteries or veins?
Arteries.
Veins. Compliance veins more than compliance arteries. Understand? Veins are